Hello, and welcome to Team Innovate Labs. I'm team leader Daniel Ramirez, and it is with great honor that my team and I take this moment to present to you the fruits of our labor and efforts. Now, a couple weeks ago, you and your band came to us looking for quick solutions to some problems you guys had before you head out on tour. Well, I'm pleased to tell you that we've come up with some innovative solutions to your problems, and so without further delay, I'd like to propose these innovations to you so that you and your band can get on the road to making some good music and a little bit of cash.
Here at Team Innovate, our mission is to exercise efficiency, quality, and creativity to achieve the goal of our customers. You came to us wanting 4 instruments that were needed to play your hit single, ASU Alma Mater. At least one of the instruments needed to be a string, 2 wind, and 1 percussion. All instruments must fit in a 2x2x2 traveling case, and the instruments collectively need to hit all the notes in your hit single. Given our budget and material constraints, the criteria we set up for ourselves was a crisp sound, ease of play, a unique creative design, and overall eye-catching aesthetics. The guys and I here aim to fit these together like a yin-yang. Our first design is going to be the Mini Broom Recorder. This puppy is going to be about 62 centimeters long, about 18 centimeters wide at its widest point, and about 3 centimeters thick. It closely resembles a recorder, which is tested and easy to use. Recorders have a good mid to high range capability, and the design is also similar to a flute, which has a record of being a good high note instrument. Recorders have been used for years, so the idea of this technology has been proven, and thus our sound quality should theoretically sound well to meet that criteria. Now let's quickly get into some design aspects. First off, we have one open end, which means that it can naturally hit some lower frequencies than a 2 open-ended instrument, as a longer wavelength can fit in a 1 closed-end instrument. We also use the math equation, length equals the speed of air divided by 4 times the frequency for our hole position. We have a narrow tube to favor the upper register, and we've also used a PVC Fipple design, which will speed up the air over the hole of the PVC pipe and cause the vibrations needed to create sound. All this under the cost of $8. In reaching our decision, we started off with a garden hose design and a plunger flute for mid to high notes. The biggest problem with the garden hose was replicating the French horn mouthpiece and the placement of the tone holes. The plunger flute idea had given us a bell end where the plunger was at, which was not so good for flute acoustics, and I was worried about the consistency of the typical flute embouchure mouthpiece. But the plunger got me thinking small cylindrical object but with an easier mouthpiece. Voila, the broom recorder idea was born, yielding a higher total among the set criteria.
And so, I'm fully confident that this design, as well as the other designs, are going to be a huge success. And so now I'm going to pass it over to my teammate David, who's going to give you a little insight on his design.
Thanks for that great introduction, Daniel. Like you said, my name is David Gwynn, and I'm going to be working on the percussion side of our project. As a team, we worked on and brainstormed 3 different ideas for each one of our designs for our instrument. The 3 designs I came up with would be a simply supported one with pipes, a cantilevered with bars, and another cantilevered one with bars as well, with metal bars. This would be wood bars, and these would be the pipes. The final design we decided to go with would be the pipes. The reason we chose the pipes is because we could get the best sound out of it, and one of the other reasons I really like the pipes is because I'm able to change the material very easily, change the length and the diameter fairly easy as well. The way we're going to have this instrument set up is I'm going to have it simply supported, and each one of the pipes on the simply supported will be resting on 2 posts. Those posts are so we can keep the amount of surface area from the instrument. So when we hit that percussion instrument, that frequency is resonating through the pipe and not through the wood, and it's not getting lost. We are also going to use a couple different materials, looking at couple different types of metals, a few different types of wood, bamboo as well. Looking forward to doing this. And next up we have Ryan. Here you go, Ryan. Oh, heads up!
Huh? What was that? Ouch! David! That hurt! Hi there. My name's Ryan, and I'll be bringing you the science behind your brand new state-of-the-art string instrument. Without further ado, let's show you the blueprint for your wooden bowl banjo.
The inspiration for this instrument came from a wooden fruit bowl that was obtained secondhand. A frame was designed using the same maple wood that the bowl was made out of. The decision to use phosphor bronze strings was driven by their cost and their mass. They're pretty cheap, $5 for a set of 6 strings, all different sizes, and heavy enough to withstand the tension needed to create a versatile range of notes. Using a string diameter provided by the packaging of the strings, the following was quickly calculated. First, the volume of each string used. Second, the mass of each string. And third, the linear mass density of each string. Using the linear mass density of my strings, MATLAB was used to calculate the length of string needed to reach each note. The low notes of ASU's alma mater are displayed against the different strings that were available. Both the low E and the A were capable of reaching all the notes themselves. However, this would have caused difficulty playing, because the notes would have traveled all the way down the neck of the banjo. Since a main criteria is ease of play, a length variance was set at a maximum of 6 inches between notes. Using these parameters and also assuming the length minimum to be 12 inches, using that information, the A, D, and the G string are capable of producing all 9 frequencies at lengths ranging from 14 to 20 inches, or 0.37 to 0.50 meters. As you can see, where other designs fell short, the banjo exceeded. It is surely the best design for this job. Team Innovate is confident that you will be completely satisfied with your decision to use our Band in a Box.